Hello everyone. In this session, we will discuss about Kubernetes architecture. So Kubernetes architecture means Kubernetes is having a cluster setup. So we will be having a master or client server kind of architecture where container orchestration engine, which is Kubernetes, it will be setting up as a control plane on one of the Linux machine, and other Linux VM or virtual machines will be working as a worker node. So master, sometimes we refer master as a control plane as well, or you can say as a COE engine as well. So master, whenever you refer it, it means you're talking about the Kubernetes engine. Okay, Kubernetes COE engine. Okay, it has four components. One is API server. As in the previous session, I have explained you that Kubernetes is a API based product where each of the component has defined in the form of API. Then you have etcd, that is you can say is the database where exactly it will be storing all the component details, because we are creating a setup something like that where one virtual machines is there where you will be setting up the COE, or some people refer that as a control plane or maybe master, and all this component will be storing there. And then other virtual machines where you want to spawn the container, the component will be stored, respective component will be stored on that only. Okay, so this is the kind of setup we will be creating it up. So or etcd is the database scheduler. In the master, where exactly the container should be scheduled will be decided by the scheduler. Controller manager is performing the controlling mechanism. Like, okay, if I want to create three replicas of particular application container, then the three replicas are keep on running it. They will be always matching with what number of replicas has been mentioned in the control plane that is taken by care by controller manager. There are multiple different type of controller manager will be available there. Similarly, worker node, this is another Linux machine. You will be setting up kubelet. We will discuss in detail container runtime and kubeproxy. Here you can see I have mentioned docker forward slash container runtime. It means Docker is not necessary must a container runtime. It can be anything. Container runtime can be container D. In case of OpenShift, it is Cryo. So anything can be used as a container runtime. It must be recognized by CNCF that you can use as a container runtime application. This is the setup which mostly AV organization created. This is the master control plane or COE. Okay, here all these components are there. This is the another set of Linux VM. Okay, so Linux VM will be having one or more than one, but Linux VM you can put it as a worker node depending on the workloads. So kubelet is there, this Docker or container runtime is there, and kubeproxy is there. So we will understand why it is required. Okay, let's understand each component in detail. So as I initially mentioned, Kubernetes is a API based solution. So whenever I will be creating or submitting some request, it will be in the form of API. So someone has to validate my API, and that is the component which is validating my API is API server. Whether you submit the request in the form of API, you're using web interface or you're using command line, all this request will be going to address by API server, because Kubernetes has predefined API that is in the define that definition is stored in the API server. So validation part will be taken care by API server. So if I say API server, what is API server? API server is the front end for the end user or for the system admin, whether they are requesting from any form, whether API, command line, or web interface or command line. Okay. So Kubernetes API server validates and configure the data for the API object, which include pods, services, replication controller, other resources. For now, these you can take as a Kubernetes API resources definition. We will discuss in detail what exactly it is. API server services the REST operation. REST operation is like get, put, post, delete, modify, all these operations they can serve it for the component. API server is a component of Kubernetes control plane that expose the Kubernetes API. So it means there are predefined set of APIs are available in the Kubernetes, which is the part of API server. So whenever you submit the request, the first thing will be part of the validation. API server is the front end for the Kubernetes control plane. It means as a system admin or Kubernetes admin or maybe end user, you will be interacting with the API server only. API, since this is the microservice architecture, it can scale up horizontally as well. Second component is etcd. Etcd is those who are coming from the Linux background. Etc is uh, in the Linux file system. Etc is a directory structure which keeps the configuration information about the Linux operating system. Similarly, etcd name inspired by etc only. Etc directory in Linux store the configuration file. D is for the distributed architecture. Since the etc is a distributed configuration directory structure for Kubernetes. etcd is the open source project. This means it is not developed by Kubernetes. It is already available. You can go and Google etc. You can find it out. Store the metadata information for consistency and fault tolerant way. So if I suppose I create a container, which worker node the container is running it, what is its state, whether it is healthy or not healthy, what is the IP address, and everything will be stored in the etcd. So it stores the configuration data. It will be used for service discovery and cluster management. Okay. And master keep on monitoring the etcd and roll out the changes as well. Kubernetes persist cluster state into the etcd. So it means suppose I want to create this diagram. I there is a container is running here. Where exactly the container has created, what is its state, whether it is running healthy or not healthy, everything is stored under the etcd. Similarly, worker node state, cluster consistency state, everything is stored under etcd. So API server will be monitoring the etcd to address the things. Okay. Then comes alternative of etcd, Zookeeper and console. Two other alternatives are also available, which you need to configure explicitly if you are not going for the default installation. Then comes to the scheduler. Scheduler, where exactly the cur- workload should be scheduled in the form of container, that is taken care by scheduler. So control plane component that watches for the newly created pods which is not assigned node, select a node for them to run out. Factors taken in the consideration is affinity, anti-affinity, data locality, inter-workload interference, deadline, hardware, software constraint. So many things are there, which we will discuss it when we will discuss about Kubernetes, multiple different component and pod affinity, node affinity, label selector, taint toleration. I will be discussing in detail. Then important part comes is the kube control manager. Okay, for understanding purpose, it's a single binary. Okay, many different control managers are available for different purpose. As I told that, okay, replicas is like I want to run multiple copies of same application. So I can use the replication controller. Replication controller is the part of Kubernetes controller manager binary only. Its whole role is, if I mention three replicas must be created, it will keep on monitoring it. If one of the replicas goes down, it will again restart it. So different type of controller managers are available, like node controller is there, job controller is there, endpoint controller, service account and token controllers. We will discuss each of the controller manager rules in detail when these APIs will come in the picture. Rest of the component like kubelet, kube proxy, and container runtime, I will be discussing in the another session. So for summarize this thing, Kubernetes control plane or master has four major component. One is etcd, controller manager, API server, and scheduler. Sometimes it is master is referred as a control plane as well and COE as well. It is a virtual machine. Top of that, we will be installing Ubuntu or any other Linux player. And top of that, we will be setting up all this master component using kubeadm tool in this session. There are multiple other distributions are also available in form of minikube, that is for learning purpose, or K3s distribution is also there, which you can use it as a service. Also it comes like AKS, GKE and other things we will discuss when we will discuss about the installation mechanism, what are the options are available. Thank you for joining this session.